Particle physics. Today we will discuss about the classification of particles, fundamental forces and standard model and Large Hadron Collider. So what are the fundamental forces present in our universe? There are four fundamental forces and the strongest one is strong nuclear force and the second strongest one is electromagnetic force. Then comes the weak nuclear force or weak forces. Then the weakest of all the four forces, that is gravitational force. So example for the strong force is our nuclear force, which hold the nucleon together inside the nucleus. And we know that the electromagnetic force, which include the electric force and electrostatic force, electrodynamic force, magnetic force, etc., will come under this category. And weak force, which involve in beta decay. So it's also a nuclear process. This will happen also inside the nucleus, and this force is known as weak force. Example for the weak force is beta decay force. Then comes the gravitational force. There are certain forces. So the function of the strong force is to bind the matter together because it will give stability to the nucleus. So it hold the nucleus, then as a result atoms, as a result molecules. So it is responsible for the stability of matter, or it bind matter together. And the function of electromagnetic force, which is responsible the force between charges, currents and forces between the magnet, and also it is responsible for the electromagnetic radiation, that is the interaction of light. And the weak force, that is weak nuclear force. An example for the weak nuclear force is beta decay, which gives stability to the nucleus. And the gravitational force and its function responsible for the force between the heavy masses. It gives stability planets, stars, galaxies. So in this chapter we are discussing about the particle physics. Here also there are certain particles which are exchanged during the interaction of the force. These particles are responsible for this interactions. So here the particle which is responsible for the interaction of the strong force are gluons. Gluons are exchanged during the strong interaction, and which are responsible for the which are the particle. This type of particle we called as the field particles, which are exchanged during the interaction. So these type of particle which are responsible for, which are exchanged during strong interaction, is known as gluons, and the particle which are exchanged in electromagnetic interaction is known as photons. We are familiar with photons, which are the quantas of energy. So these particles, photons, are responsible for electromagnetic force or electromagnetic interactions. So they are called the force carriers. So the force carriers in electromagnetic force are photons, and the force carriers in the weak nuclear forces are W and Z bosons. And the particle which is responsible for the gravitational force, or the particle which are exchanged during the action of the gravitational force, are called gravitons, and these are the force carriers in the gravitational field. This not yet discovered. These gravitons are theoretical predictions, but it practically not discovered yet. So that about gravitons. These these particles, we call these particles as field particles because they are responsible for field interaction. These particles, that is gluons, photons and W and Z bosons and gravitons, are field particles, okay, which are exchanged during the interaction of the force. And also we call these particles as force carriers. Okay, these all particles have integral spin. We already studied about spin in your +2 classes. So they all have spin. So the particle which are exchanged, or which are the force carriers are known as the field particle. An example for the field particles are gluons, photons, W and Z bosons, and graviton. In these particles, gluon, photon, and W and Z bosons have spin 1. They all have spin 1. And this graviton has spin 2 particle. So photon also have spin 1. This diagram will give you an idea about the relative strength of the forces. Suppose we are giving a strength of 1 to the strong force, then electromagnetic force have a strength of -2, weak force have a strength of -5 to -13, and gravitational force have a strength of around 10 raised to -40. So from this comparison we can understand how the strength varies. So the strong force have strength 1, electromagnetic compared to the strong force, electromagnetic force is 1 by 100 times weak, and this is 10 raised to -5 times weaker, and the gravitational force is around 10 raised to -40 times weaker than the strong force. Normally the range, the strong force is acting inside the nucleus, so its range is very small. It is in the order of 10 raised to -50 because it is acting inside the nucleus, and the radius of the nucleus is 10 raised to -50. So the strong force, its range is 10 raised to -50. If the range is greater than this strong force will vanish. Okay, then electromagnetic force, we know that the Coulomb's law or Weierstrass law will deal with electromagnetic forces. So its strength is varies as 1 by r square. In order to get zero strength to electromagnetic force, its range should be infinity. It's a theoretical value, infinity. So up to infinity, the strength of electromagnetic force can vary. Then what about weak forces? We know that the weak forces are also acting inside the nucleus. So it is also in the order of 10 raised to -17, or it is in the order of 10 raised to -15. It is also okay. So because it is acting inside the nucleus. So its strength is around 10 raised to -17 meter. And what about gravitational force? Gravitational force is also varies as 1 by r square. So it will theoretically equal to 0 when r is equal to infinity. So it have an infinite range. This about the range of forces, and we know that normally we call that strong force as mediated by gluons, and the electromagnetic force is mediated by photons, and the weak force is intermediate boson, that is W plus W minus and Z0 bosons, and gravitational force is known as by a particle known as graviton, and graviton have spin 2, photon has spin 1. Okay, you will remember only about this photon and graviton. Okay, don't bother about other particles. So let us discuss about the classification of particle. Normally, it depends upon the spin. So we already know spin, intrinsic spin of the particle. We can classify particle into two, that is fermions and bosons. Okay, fermions have half integral spins and boson have integral spin. So half integral spin means half h cut, 3 by 2 h cut, 5 by 2 h cut, etc. So listen here. This is half integral spin particle. It have a spin of half h cut, 3 by 2 h cut, 5 by 2 h cut, etc. So fermions have spin half, 3 by 2, 5 by 2, etc. And what about boson? Boson are integral spin particle, have spin 0, 1, 2, 3, etc. So they are integral spin particles. Bosons are integral spin particles and fermions are half integral spin particles. This is one type of classification. Particle can be classified into different type, and it is one type of classification is particle can be classified into depends upon its spin. So half integral spin particle, they are called fermions. They have spin half, 3 by 2, 5 by 2, etc. And boson have spin 0, 1, 2, 3, etc. So that about the class one type of classification of the particle. This is a vague type of classification, and we have to go for more precise type of classification. So in general, a particle can be classified into matter particle and field particle, and the particle which are responsible for the formation of matter is known as matter particle, and the particle which are exchanged during interaction of the force is known as field particle. We already discussed about field particle. Example for the field particles are gravitons and photons, and photon have spin 1 and graviton have spin 0. So we know that matter particle which are responsible for the formation of matter, that is this matter particle are responsible for the formation of atoms, molecules, and like that. So we already know that there are four fundamental forces. Depends upon whether the particle are affected by strong force or not. We can classify particle into two types. Depends upon whether they are acted upon by strong force. ഈ പാർട്ടിക്കിളിന്റെ മുകളിൽ സ്ട്രോങ് ഫോഴ്സ് എഫക്ട് ചെയ്യുന്നുണ്ടോ ഇല്ലയോ എന്നതിൻ്റെ ബേസിസിൽ പാർട്ടിക്കിളിനെ നമുക്ക് രണ്ടായി ക്ലാസിഫൈ ചെയ്യാം. സ്ട്രോങ് ഫോഴ്സ് എഫക്ട് ചെയ്യുന്ന പാർട്ടിക്കിളും സ്ട്രോങ് ഫോഴ്സ് എഫക്ട് ചെയ്യാത്ത പാർട്ടിക്കിളും. The particle which are affected by strong force and particle which are not affected by strong force. The particle which are not affected by strong force is called leptons, and the particle which are affected by the strong force is known as hadrons. So they are hadrons. So what are leptons? Leptons are matter particle which are acted upon by, which are not acted upon by strong force. And what are hadrons? Hadrons are matter particle which are acted upon by strong force, which is known as a hadron. And leptons, all the leptons are fermions and they have spin half. All the leptons have spin half. So half is an half integral spin, so they are all fermions. All the leptons are fermions. There are 6 particles. Normally every particle have an antiparticle. Now we will discuss about particle only, but you have to know that for every particle there exists an antiparticle. Okay, so there are 3 type of lepton: electron family, muon family, and tau family. And electron family have 2 members, electrons, and this is known as neutrino, and this is electronic neutrino. So the leptons are electronic neutrino. Muon, this is known as muon particle, muon and muonic neutrons. Tauon and tauonic neutrino. So electron in electronic neutrino, muon and muonic neutrino, tauon and tauonic neutrino. This is known as neutrino, nu. Okay, we used this letter to denote frequency. There is no relation between frequency. Anyway, to understand the letter, it is nu. So electronic neutrino, these are neutrinos. So this electron have a negative charge. These neutrino are chargeless. All the neutrinos are chargeless. So electronic neutrino, muonic neutrino, and tauonic neutrino, all are chargeless particle. Electron have a charge of -1, muon have a charge of -1, tauon have a charge of -1. So all the particles here in this lepton family have a charge of -1. Okay, these leptons are purely or truly elementary particles. They are made up of themselves. That means we cannot split these leptons into further smaller particles. So leptons are truly elementary particles. So our familiar electron will come under this lepton family. And one other important particle of this family is positron. That is, the antiparticle of electron is known as positron. Okay, so positron is also a lepton. All these six particles have their antiparticle. Antiparticle means a particle with a similar mass but opposite charge. So this positron has positive charge and have a mass of electron, and also the spin is same as that of particle. There is no change in their spin. So they are called antiparticle. So this family have six antiparticle also. All the particle have antiparticle. All particle have their antiparticle. Okay. So the total number of lepton is 6. There are only 6 particles in this lepton family, or we can call that the lepton family is very closed. Closed means no other particle can added into this family. So there are only 6 particle and 6 antiparticle. Totally 12 in number. The 6 are particle and 6 are antiparticle. Here the particles are electron, electron neutrino, muon, muon neutrino, torr neutrino, and its antiparticle is positron and anti-electron neutrino. Mu plus and anti-neutrino of muon, or muon anti-neutrino, and tau plus and anti-neutrino of torr, that is torr anti-neutrino. So neutrino, if particle is neutrino, its antiparticle anti-neutrino. We call them as an anti-neutrino. So neutrino and anti-neutrino are particle and antiparticle. Okay. So this is closed. Only 6 members. No addition is possible in the case of leptons. They are Now let us discuss about hadrons. So what are hadrons? Are particles which are affected by the strong force. Actually, leptons are affected by weak force and electromagnetic force, and they are not affected by strong force. Okay. Now let us discuss about hadrons which are affected by strong force. So hadrons can be divided into 2 groups based upon their spin. So based upon their spin, we can classify hadrons into 2 groups. They are mesons and baryons. So what are baryons? Baryons are half integral hadrons. Okay. And let us discuss about mesons. So these mesons are integral spinned hadrons. So based upon we classify the particle hadrons on their spin, that is integral spinned particle, they are known as boson. Half integral spinned particle, they are known as baryons. And the important, we can discuss about 3 important group of particles coming under this meson family. There are a lot of particles. We will study only about 3 type of particles because our portion is restricted to this. Okay, there are a lot of particles will come under this meson family. We only discuss about the 3 mesons. They are pions. Pion family have 3 members: pi plus, pi 0, and pi minus. And chion, a chion family have only 2 members: K0 and K plus. And eta family have only member eta 0. All these are boson, means they have integral spin, and the spin of pions, chion and eta mesons are 0. And pion have 0 spin, chion have 0 spin, and eta meson also have 0 spin. Okay. And the number is not restricted into 3. There are a lot of members. There are many members in this family. We will discuss only about the 3 members. That is pi plus, pi 0, pi minus. All these particles have their own antiparticles. Okay. Now let us discuss about baryons. Baryons are hadrons and have integral spins. Half, 3 by 2, 5 by 2, etc. Okay. So they are fermions. All the baryons are fermions. Some of them have spin half. Some of them have spin 3 by 2. Like that. So they are all fermions and so the members of baryon family are nucleons, lambda, sigma, psi and omega. And there are also a lot of members in this family. We will study only about these members. They are important members. There are a lot of members. They are not closed. Closed means there is no addition is possible. They are not closed means there are a lot of members. We will study about only few members. Okay. They are nucleons, lambda particle, sigma particle, psi particle, omega particle. Okay. Nucleon, we know, we are very familiar about nucleons. Nucleons are the particles which are present inside the nucleus. They are protons and neutrons. So the nucleon family have two members. They are protons and neutrons. And lambda family have only one member. This is lambda 0. Sigma family have three members. Sigma plus, sigma 0, sigma minus. Psi family have only two members. Psi minus and psi 0. So this is psi minus and psi 0. Omega part. Omega have only one member in this family, that is omega minus. Okay, so that are the importance baryon. These neutrons and protons have spin half. We know that neutron have spin half and proton have spin half. Proton have a positive charge, neutron have a charge 0. And also their antiparticle is present. Lambda also have spin half particle. Sigma also spin half particle. Psi is also spin half particle. But omega is a particle with a spin 3 by 2. It have a spin of 3 by 2. Okay. So here also this particle and particle also have their antiparticles. And so these leptons are truly elementary particle, means they are made up of themselves. But these mesons and baryons are further, or it is composed of some other smaller particles. They are not truly elementary particle. They are composed of some other smaller particle and it is known as quarks. So the mesons and baryons are made up of quarks. Okay, hadrons are made up of, so these hadrons are made up of quarks and meson is made up of one quark and an antiquark. Okay, so the meson is made up of two quarks, but the baryons is made up of three quarks. Baryon is made up of three quarks. They are all particle quarks. They are not anti-quarks. They are made up of three quarks. And meson is made up of a quark and an antiquark. Actually, quark is a very simpler particle having a fractional charge. Okay, these quarks have a fractional charge, and these hadrons are made up of these quarks. Okay. But lepton is not made up of quarks. It is truly elementary particle. It is made up of itself. Then standard model. നമുക്ക് സ്റ്റാൻഡേർഡ് മോഡലിൻ്റെ വളരെ ബേസിക് ആയിട്ടുള്ള കുറച്ച് കാര്യങ്ങളെ പഠിക്കാനുള്ളൂ. ആക്ച്വലി ക്വാക്സ് നിങ്ങളുടെ സിലബസിൽ ഇല്ലാത്തതാണ്. അപ്പോൾ അതുകൊണ്ട് വളരെ കുറച്ച് കാര്യങ്ങളെ പഠിക്കാനുള്ളൂ. ഓക്കെ, എന്താണ് സ്റ്റാൻഡേർഡ് മോഡൽ, അതേപോലെ എന്താണ് ഹിഗ്സ് ബോസോൺ, എന്താണ്, അങ്ങനെ കുറച്ച് ടേംസ് നിങ്ങൾക്ക് ഫെമിലിയർ ആവാനുണ്ട്. So let us discuss about the standard model. We already studied that. നമുക്കറിയാം 4 ഫണ്ടമെൻ്റൽ ഫോഴ്സസ് ആണ് നമ്മുടെ നേച്ചറിലുള്ളത്. അതിനെ ഒരു സയൻറ്റിസ്റ്റുകൾ അതിനെ ഒന്ന് യൂണിഫൈ ചെയ്ത് ഒരു സിംഗിൾ ഫോഴ്സിൽ നിന്ന് ഒറിജിനേറ്റ് ചെയ്തതാക്കി എടുക്കാൻ വേണ്ടി 4 ഫോഴ്സുകളെയും ഒരു സിംഗിൾ ഒറിജിനിലേക്ക് കൊണ്ടുവരാൻ വേണ്ടി ശ്രമിക്കുന്നുണ്ടായിരുന്നു. അത്തരം ശ്രമത്തിന് നമ്മൾ നോർമലി വിളിക്കുന്ന പേര് യൂണിഫിക്കേഷൻ ആണ്, ഫോഴ്സുകളുടെ യൂണിഫിക്കേഷൻസ്. അപ്പോൾ ഇവിടെ ഈ 3 ഫോഴ്സിനെയും യൂണിഫൈ ചെയ്യാൻ നമുക്ക് പറ്റിയിട്ടുണ്ട്. അങ്ങനെ യൂണിഫൈ ചെയ്ത് കൊണ്ടുവരുന്ന ഒരു മോഡലിനെയാണ് നമ്മൾ സ്റ്റാൻഡേർഡ് മോഡൽ എന്ന് പറയുന്നത്. ഓക്കെ, അവിടെ യൂണിഫൈ ചെയ്ത ഫോഴ്സ് എന്ന് പറയുന്നത് സ്ട്രോങ് ഇലക്ട്രോമാഗ്നറ്റിക് ആൻഡ് വീക്ക് ഫോഴ്സ്. അവയ്ക്കൊരു കോമൺ യൂണിഫിക്കേഷൻ പോസിബിൾ ആണെന്നും അപ്പോൾ അവയിൽ ഇൻട്രാക്ട് ചെയ്യുന്ന പാർട്ടിക്കിളിനെ കുറിച്ചിട്ടും പറയുന്ന ഒരു മോഡലിനെയാണ് നമ്മൾ സ്റ്റാൻഡേർഡ് മോഡൽ എന്ന് വിളിക്കുന്നത്. സോ വാട്ട് ഈസ് എ സ്റ്റാൻഡേർഡ് മോഡൽ? So it is a theory describing 3 fundamental forces, that is strong, electromagnetic and weak forces in the universe, and classify all the non-elementary particles. It's a unification of this standard model is a unification of strong electromagnetic and weak forces, and so the particle will come under this standard model are this particle. There are 6 quarks and there are 6 leptons, and we have a gauge bosons or field particle. There are 4 type of gauge particles, and along with there is one particle that is known as Higgs boson. And the quark is up quark, down quark, champ quark, strange quark, top quark and bottom quark. This can be represented by U, D, C, S, T and B. And the lepton is electron, electronic neutrino, muon, muonic neutrino, ton, tonic neutrino. And these are the gauge bosons. This is gluon, and this is photon, and this is Z boson, and this W boson, and H represent the Higgs boson. All the three, this particle will the truly elementary particle of the universe according to standard model. Higgs boson, it is a fundamental particle associated with Higgs field. It's a field that gives mass to all the fundamental particles such as electrons and quarks. So the particles will get mass when it is interact with this Higgs field. And another one is a grand unified theory, that is known as GUT. So a grand unified theory is a model in a particle physics in which high energy, the 3 gauge interactions of standard model comprising of electromagnetic, weak and strong forces are merged into a single force, and this theory is known as the Grand Unified Theory. Next, let us discuss about the Large Hadron Collider, LHC. It is world's biggest and most powerful particle accelerator. It was built by European Organization for Nuclear Research, which is known as CERN. It is a giant circular tunnel built in the underground. Okay, that's about Large Hadron Collider, and it is situated in Geneva, Switzerland. That about Large Hadron Collider.